friends, today we will continue our discussion on semiconductor laser. In the previous video, we have seen that what is a laser, and we have also discussed about the invention history of laser. Further, we have seen what are the different types of lasers and what are different types of electron transitions. Finally, we have seen that in case of a laser, the stimulated emission of radiation dominates over absorption and spontaneous emission of radiation, right? So today we'll look into some of the important concepts which are essential to understand the laser activity, and after that you will be knowing why the intensity of the light increases in case of a laser. Let us now understand some other terms like population inversion and pumping. Here I have drawn two states. This is the ground state and this is the excited state. And generally at thermal equilibrium, the electrons, they used to be in ground state, right? So these are the electrons which are there in the ground state. If somehow some of these electrons, they get energy from some external source, and that energy is more than E2 minus E1, then they will move to the higher energy state. So some of the electrons, they will start moving to the higher energy state, and when the number of electrons at the higher energy state is more than the number of electrons in the lower energy state, and that is known as population inversion. So population inversion is the case where more carriers are there in higher energy state as compared to the lower energy state, and the number of occupied excited states is greater than the ground states. This is for a single atom. If we will consider number of atoms, then the number of occupied states is greater than ground state. Now if N2 is the number of electrons in the excited state and N1 is the number of electrons in the ground state, then for population inversion to occur, this should satisfy this condition. N2 should be greater than N1. And we know that the electrons, they cannot move by their own to the excited state, right? To move an electron from the ground state to an excited state, we need to supply some energy, right? So to achieve population inversion, we need to supply energy to the laser medium, and the process through which we are supplying the energy to the laser medium, that process is known as pumping. There are different methods of pumping. The first one is optical pumping, where light radiation is used to supply the energy. Second one is electrical pumping, where accelerated electrons, they are used for this pumping method. Chemical pumping, where chemical reactions are used for supplying the energy. Thermal pumping, where heat radiation is used for pumping. And the case we are considering now, in that case, it occurs due to direct conversion. So what is direct conversion? During the recombination process in direct band gap semiconductors, the electrical energy is being converted into light energy. So this is what called direct conversion, and this is the methodology which is used for semiconductor laser. The next concept I am going to discuss is resonant cavity or optical cavity. This is a very important concept for this laser. This resonant cavity or optical cavity is a special arrangement where photons are bounced back and forth to enhance the light intensity. And generally it is made up of two parallel reflecting surfaces. That surface may be, for example, we can take it as mirror. So for this arrangement, there are two parallel surfaces kept in the laser medium, and these two surfaces are reflecting in nature. So what happens in this case, if this is a photon over here, when it moves and hits the other surface which is parallel to the first one, this is the first surface, this is the second surface, and this photon, it started from here and it hits this second surface. Once it hits the second surface, it will bounce back and it will move to the first surface. Again, after hitting the first surface, it will bounce back and it will go to the second surface. From there, it will come here, again it will go to the second surface. So it is moving to and fro within these two reflecting surfaces, right? While it is moving to and fro within these two surfaces, during its motion, it will hit some other electrons in the excited states, and that will initiate spontaneous emissions. And because of that spontaneous emission, we are getting high intensity light in a laser. Further, if these photons are moving within these two plates, then how we are getting the light from that laser? For that purpose, one or both of the surfaces are made partially transmitting in nature, through which fraction of light leaks out as output of the laser. Let us understand this. One or both of the surfaces are partially transmitting in nature. Either one of these two or both of these surfaces, they are made partially transmitting. Partially transmitting means, if this face is made partially transmitting, then part of the light coming to this surface, they will be reflected, and part of the light will transmitted out of the surface. Okay, similarly, if this is also made partially transmitting, part of the light will be reflected back towards the first surface, and part of the light, they will be transmitted through this surface. So these transmitted light through these two surfaces, they are the outputs of the laser source. If one is partially transmitted, then we will be getting from one side. If both are partially transmitted, then we will be getting the output from both the sides. So these are some of the terminologies which we will be using in this unit as well as your next unit. Hope you understand the concept. Thank you all. If you like the content, please press the like button and share the link with your friends. Further, please do subscribe the channel so that whenever I am uploading a video, you will be getting the notification.